Good afternoon, and welcome to this webinar for the DToceanPlus consultation. My name is Encarni Medina Lopez, and today I will be introducing this session together with my colleague Donald Noble. Welcome from sunny Edinburgh. As a plan for this webinar, we will introduce DTOcean and DToceanPlus. Then, we will be presenting the aim of the consultation. We will give an overview of DToceanPlus, followed by the main tools within it. First, the Structured Innovation Tool, which will be introduced by Energy Systems Catapult. Second, the Stage Gate Design Tool, presented by Wave Energy Scotland. Third, Assessment and Deployment Design Tools, presented by Tecnalia. Finally, we will introduce and explain the consultation questionnaire. Some of you will be familiar with DTOcean already, but some of you might not be. So for clarification, this DToceanPlus project is the next stage of the DTOcean project, which finished in 2016. The goal of DTOcean was to accelerate the development of ocean energy by developing design tools for ocean energy deployment. DToceanPlus builds on that. The project started in May this year, and now we are going to develop advanced design tools for ocean energy systems innovation, development, and deployment. The goal of this consultation is to understand and refine user needs. For this purpose, we intend to collect inputs from different stakeholders in a multi-level approach. We will produce user requirements in terms of metrics, functionalities, and demonstration case studies. This user consultation is divided in 3 sections. The first one is this webinar that we are using to explain the project and propose tools. The second is a questionnaire to gauge user needs. The questionnaire is already open, and you can access it from the webinar invite that you received. The third section of this consultation are some follow-up interviews that we will have with key stakeholders. Focusing now on the objectives of this project, DToceanPlus will develop and demonstrate an open source and integrated suite of second-generation design tools for ocean energy systems. This will focus on subsystems, devices, and arrays. It will support the whole technology innovation process, from concept through development to deployment, and it will be relevant to a wide group of stakeholders. This goal will be achieved using the tools that we have in the figure. We have the Structured Innovation Tool for concept selection, then we have the Stage Gate tool for technology development, and we also have the deployment tool to reach commercialization. These tools are interconnected by a set of assessment tools. And these links will be possible thanks to the underlying digital models, which will provide a standard framework for description of ocean energy systems. These digital models will also be the communication method for the tools, and they will develop a common language for the whole sector. Now we are going to explain the different tools in detail, starting with Nick Arrow from the Energy Systems Catapult. He will be presenting the Structured Innovation Tool. So, Nick, I'm giving you access. The floor is yours.
Thanks, Encarni. Good afternoon, everybody. My name is Nick Arrow. I'm going to talk to you very briefly about the first of the 3 sections there, as Encarni said, the structured innovation tools within the overall toolset. The aims of these particular tools are really around, firstly, capturing the voice of the stakeholder and really understanding what the requirements are of the various stakeholders. It then provides an innovation toolkit based on validated data and validated methods that in some cases are well-established practice in other sectors, and our aim is to capture that best practice and enable people to implement those into the ocean energy sector to really improve the possibilities within the ocean energy sector. As Nkani said, there are also links to all the other tools in the tool set, and particularly to the stage gate design tools, as it feeds through potentially innovative solutions, priorities, and also some information about risks. If we could move on to the next slide, please. Thank you. So within the structured innovation tools, which was the left-hand side of that circular figure we saw a moment ago, we have got 3 tools within that section, and each of those is represented on this chart here. So I'm going to just start on the left-hand side and work across. The first tool within the structured innovation set is quality function deployment. Some of you may be familiar with some of these tools, some of you not, so I'll give a very brief introduction to each one of these in turn. This is very much the QFD, very much around enabling you to structure and also prioritize the requirements of a whole range of different stakeholders to understand the relative importance and interactions of those requirements. So there could be anything from things like capital and operating costs, energy yield, environmental impact, and a whole range of other requirements that various different stakeholders may have at different levels of importance and of granularity. And the ability to work at different levels of granularity is a theme which will recur throughout these tool sets, so to make the tools as usable as possible. And the QFD tool not only will help you to capture those and assess them, but it also then goes on to enable you to assess any potential solutions which you might have, and to understand how well each of those solutions might actually meet each of the requirements in turn. And so coming out of that tool set, typically you would have a set of clearly delineated requirements, a set of potential solutions perhaps that you may already have that have then been assessed against those requirements. And potentially you might have a set of development priorities as to how you could maximize the impact of your next work and make your potential products as effective as possible. That then feeds into the second of the 3 tools on this chart, which is a technique called TRIZ. TRIZ is actually a Russian-based tool originally, and is actually a set of tools. It's kind of multiple techniques that enable you to create conceptual ideas where you have a problem statement to help you think about how you might generate new solutions, whether those are completely new concepts or new components, new ways of doing components within an established design. It can deal just as well at multiple stages through your development life cycle. And it's really understanding where improvement is needed and how you might be able to generate new solutions. And the TRIZ technique uses a whole series, there are nearly 40 different defined problem-solving techniques that are used as a series of lenses and prompts to help you to think differently about the problem and to pull existing knowledge from different places and from different people and to provoke that innovative spark. It gives you ways that you can identify new solutions to the problems. That in turn then feeds into the third technique, which is the failure modes and effects analysis, FMEA. That tool allows you to assess the impact of any design weaknesses or defects or errors in the engineering concepts, so you can understand what those failure modes might be, how your solution could potentially fail, what the impact of any such failure or weakness might be, and particularly then to go on and quantify the risks and the resultant costs of any such failures. So coming out of that, you might get, for example, a set of priorities for the risks that you appear to have residual at that point, and priorities for cost reduction opportunities to reduce those risks and therefore the overall cost of the product, for example. So the three tools presented there all fit within the structured innovation tools. They are all established techniques in some industries, but need to be brought to bear in this industry. So if I could move on to the next slide, please, Inkani. Thank you. So in summary here, really, the three tools taken together play particularly to different stages in the development life cycle. This is represented in the chart in the top right. So firstly, highlighted in the blue to the left of that chart is the definition stage at the beginning, and unsurprisingly, the QFD technique plays particularly strongly and effectively into that area, identifying requirements and potential solutions to address those requirements and really understand what the customer really wants. As you move to the right, that technique becomes less effective, but TRIZ can then fill that gap of how do you actually generate new solutions. It's all very well having assessment tools, but you need some way of provoking that innovation to actually generate the new ideas. And TRIZ plays strongly there in assessing those solutions and providing those solutions and being able to deal with conflicting requirements, things like you want more power, but you want it at less cost. Typically, those will conflict with each other, and it will give you tools to analyze how to solve those sorts of contradictions. And then finally, as you move to the right again onto the design area, it enables you to actually assess your detailed designs and come up with real mitigations to overcome the reliability problems without adding cost, for example. And so taken together, they really seek to introduce rigor and provoke innovation right at the heart of your concept creation. And there's lots of evidence that those three tools taken together are particularly effective at doing that. And so overall, really what we're about is giving the development some direction and impact per unit of development cost to really improve your innovation process, effectiveness, and costs, and ultimately get to more commercially acceptable solutions at the end of it all. So that's what I was going to say by way of introduction. Thank you very much. But Inkani, I'll hand back to you.
Okay, thank you very much, Nick. Now we are going to have Gillian Henderson from Webinar Scotland. She will be introducing the stage gate tool. So, Gillian.
Hi there. Okay, I'm Gillian Henderson from Wave Energy Scotland, and I'm going to talk to you about what the purpose of the stage gate design tool is, what this tool might look like, and how it interacts with the other tools in this DToceanPlus suite. Okay, so as has been mentioned, the DToceanPlus suite of tools is supporting technology development along the whole process, from concept creation up until commercial arrays. So I've indicated this on the screen at the moment with technology readiness levels showing 1 being the earliest and 9 being the latest in the maturity process. But along this whole technology development pathway, the stage gate design tool is providing a framework to assess technologies throughout this whole process to facilitate decision making for stakeholders and indicate where along that pathway does a technology fit. So the other tools which you'll hear about in this webinar interact with the stage gate design tool. So we've just heard from Nick, who talked about the structured innovation design tool, generating new concepts. These would be fed into the stage gate design tool, which would then assess concepts. And it would do this by using the other tools, that's the assessment and deployment tools, in order to output what a stage that technology is at, and indicate the readiness of that technology and any other steps to meet the next stage. So all the tools interact with each other. But to zoom in on the stage gate design tool, along this whole technology development pathway, the stage gate process is defined by splitting this up into clear defined stages. So for example, if I put a box around stage 1, and that's concept creation up until the development of an engineering specification, stage 2 and 3 are small and large scale prototype development, and stage 4 are the first arrays up until commercial deployment. With the stage gate design tool, this pathway is split up into these clear defined stages, and within each stage are points where you measure successive technologies, and you're able to compare technologies through the stages. So by splitting up into clear defined stages, it means technologies can be compared within a stage, the stages representing the main engineering activity and the maturity of the technology, and the stage gates being the objective measures of success. So this is where we would use any measures of success, stage gate metrics, across the whole ocean energy sector, so you can compare technologies. So this process can be used both for competing technologies to see which ones show the most likelihood of success in the process, but can also be used for an individual technology so that you can quantify the success and see it progress through the stages. So for example, you could be a technology developer who wants to understand, where does my technology lie in this whole process, and how does it compare to other technologies in the ocean energy sector? Or you could be an investor who is looking to invest in one of many technologies, and you want to understand where it lies in this process and what the work needs to be done to get it towards maturity. So the stage gates help to guide this process, and the whole purpose of it is to enable technology comparisons across the sector, identify the steps that are needed to reach that next stage, and identify areas of compliance and non-compliance. So what I mean by that is, if you were a technology developer and you use the stage gate design tool in DToceanPlus, it might highlight to you that you're not quite at stage 2, but it would highlight the areas that you need to improve in order to get that performance. And ultimately, it helps to facilitate decision making in a structured way, so that progress can be quantified and demonstrated across the sector, which will hopefully ultimately gain some confidence in the sector as investors can see technologies progress. So I've talked you through what the stage gate design tool will do, and I've got on the screen now a schematic of what this could look like. So to start off with, the inputs to this tool would be technology characteristics which define a technology. So at different stages along that technology development pathway, if you were up at the left-hand side, the early stage concepts, these technology characteristics might be the main operating principles of a wave or tidal energy device, the properties that make up the materials, and any likely failure modes. But as you move through, as you use it, as there's a more mature technology, this could be a full bill of materials and some test data from testing in real sea environments, and a full analysis of failure modes. But whatever information you've got available from a technology at any of those stages, it would be fed into the stage gate design tool through this digital model. Now, the digital model is something that you'll hear as a recurring theme as we talk about DToceanPlus, and as Incarni described, it's this common platform where data is shared and the tools can communicate with each other on this platform. So these inputs are fed into the stage gate design tool, and then the tool then pulls on whatever assessment or deployment tools are necessary at that stage in order to output a decision or an indication of readiness. So for example, at an early stage, the assessment design tools, those first 4 boxes on the left-hand side, could be the tools that you're most likely to use. So that's the system performance and energy yield, the lifetime costs. We've got RAMs there, so that's reliability, availability, maintainability, and survivability, and environmental and social acceptance. At this earlier stage, the stage gate design tool would use whichever combination of those tools are necessary to make a decision about a technology. And as you get to a later stage, the design deployment tools, which we'll hear about next from Technalia, are more likely to be used at these higher TRL levels. So that could be the site characterization, the energy capture, and the energy transformation and delivery up into the logistics. Whatever combination of tools are necessary to make a decision, the stage gate design tool will feed information into and take the information from in order to indicate the readiness of a technology and to ultimately facilitate decision making. And then finally, with this digital model, all the information that's produced would feed back in so that all the tools can communicate within each other. Okay, thank you very much.
Thank you very much, Gillian. Now, presenting the deployment and assessment tools, Pablo Ruiz Minguela from Tecnalia. Pablo, the floor is yours.
Thank you, Encarni. I'm Pablo Ruiz Minguela from Tecnalia, and also here with Vincenzo Nava from Tecnalia. Both of us have been working in preparing this presentation. Now that we have covered the technology innovation phase and technology development phases, let's concentrate on a stage where we have more mature technologies that can be deployed in first arrays and commercial arrays. The more information we will have will make it possible also to produce more detailed designs and assessments. So this new tool set will be built up on the DTOcean platform that was briefly introduced by Encarni today. Our main improvements will be in terms of giving more capabilities, design accuracy, management of uncertainties, usability of the tools, and improving the running time. We will also benefit from some new features that has been also briefly introduced, such as the digital representation of ocean energy systems that will give some consistency to all of the design stages. We will also use a standard core platform called Salome that will enable us to do a better and improved workflows during the design process. This incidentally will make it possible to work with different levels of granularity and coarseness of the input data, and also to interface with already available commercial options for several stages of the design process. So basically, the next slide, please. Yeah, the scope to be widened in terms of functionality from the first generation of tools is depicted in the graph in purple with new models, and the improved functionality in other boxes is depicted in blue. At the top of the diagram, we have the modules concerning the deployment design tools, whereas at the bottom, we have the assessment design tools. Those are the same modules that Gillian has explained before. The modules describe the different stages within the development design process, and there is a global design tool, namely the standard platform I referred to, that will have some design routines that will enable to follow up the design process and to provide optimal system designs, mainly for devices and arrays, starting from a set of user inputs and selections, drawing from a global database of components and equipment, and producing through the evaluation and assessment those improved designs that will be represented digitally in a standard format. So basically, that's the presentation of the deployment and assessment design tools.
Thank you very much, Pablo. Finally, my colleague Donald Noble is going to walk you through the questionnaire. Feel free to share any questions you might have using the webinar software. We will try to answer them at the end. Donald, your turn.
Thank you, Incarni. I'm going to talk a bit about the questionnaire we developed to try and gather information to help us better understand the user needs, and that's regardless of your involvement or understanding of DTOcean and DToceanPlus. We're really looking for input from everyone, no matter what level of understanding you have. The questionnaire is split up with about 35 questions over 5 pages. These are split into the user details, the overall DToceanPlus suite, some general comments on that, and then the tools that you've just heard about, the structured innovation, StageGate tools, and the deployment and assessment tools. It should only take about 15 minutes to complete the questionnaire, perhaps a little bit longer if you want to give us lots of really useful feedback. The questions are a mix of multiple choice, some importance rankings, and some free text input boxes where you can add as much detail as you'd like. Please use these to explain any answers or choices you've made in the importance rankings and to add in any other detail you'd like to. We'd also like to invite you to participate in further project engagement with your optional contact details. If you provide these, we'll hold on to these for the duration of the project, purely for the purposes of keeping you informed about the project. As was mentioned at the start, we would also like to hold follow-up one-to-one interviews, and if you'd be interested in being contacted regarding these, please indicate that on the questionnaire. We will also send a summary of the consultation responses if you'd like, and there's a choice to indicate that as well. Although you can respond anonymously to this question, any details you provide about your organisation will help us better understand our users. So we're looking for the type and name of your organisation, as well as your role and the country that you're based in. All of these are optional fields that you can fill in or not as you choose. However, all the responses to the questionnaire will be aggregated and they won't be individually attributable to any one person or organisation. So the first technical questions are about the project lifecycle, which we've heard about before. The idea is that DToceanPlus can be used throughout the project development, which have been split into 3 key stages linked to the technology readiness levels. These are the concept definition, feasibility, and design stages. At each of these stages will have an increasing level of information about the project. At the concept definition stage, this is just an early stage analysis of your device or site that you're considering. This will give an overview of the capabilities of your device or the potential of your site and some development steps that you need to take, but it's likely to be based on limited available data. The feasibility stage is really relating to technology development and model testing, maybe some open water testing, includes in-depth studies of the topics covered in the concept definition, and it's more accurate in these previous stages with corresponding additional data requirements. The design stage is really the commercialization of your technologies. So key features of the project are formed, will be planned at this stage, informed by the previous pages. And these will make use of detailed information about your project, as has already been mentioned. At each of these stages, we'd like to understand how likely you are to use the DToceanPlus tools, the balance between speed of computation and detail in terms of accuracy and complexity of the results. Which of these is more important to you at each of the stages? We can understand that perhaps at concept definition, you'd like to get a quick idea of how something will perform, but at the design stage, you'd rather get a much more detailed result. Or perhaps both are equally important to you. We'd also like to understand how long you'd expect you or your team to spend on data processing and inputting. This is kind of, we're trying to understand a realistic expectation of timing here, rather than how fast you love the software to run. We know that it always want things to run faster, but sort of, this is more kind of trying to get a realistic expectation. And finally, looking whether you'll be likely to get training yourself to use the software, or if you get a colleague or perhaps a consultant to run this for you. There's also some questions on usability and compatibility with other software, but these should hopefully be self-explanatory, so I'm not going to cover them in any detail. There's then some technical questions on the individual tools. Firstly, how well you understand conceptually what these tools will do. Is this clear to you from the information we've presented today and the background that's included with the questionnaire and your previous knowledge of DTOcean? Or do we need to put in some more effort in explaining them as part of this project? We'd also like to understand how likely it is you'd use each of these tools for assessing the different components or levels of your device or technology. For example, at subsystem, for example, moorings, for single devices as the technology develops, or arrays of multiple devices in the development phase. There's then some specific questions on each of the tools, which I'll cover in the next slides. And as I've already mentioned, each page has text boxes where you can add specific requirements or other comments you might have. So on the structured innovation tool explained by Nick a minute ago, we'd like to understand whether you're more likely to use this for short-term solutions to specific problems, or whether you look for more general long-term solutions towards a final goal, or are both equally important to you. We would then like to understand the importance of using structured innovation within DToceanPlus for a range of possible areas. Is it more important to you to identify and quantify challenges, or is this an area that's perhaps less important for your organization? Similarly, how important would be, for example, the design of funding calls? Similarly, for the stage gate tool explained by Gillian, I'd like to understand the importance of another similar range of possible areas. Firstly, assessing development stages of different aspects of a device, such as the reliability or lifetime cost, or perhaps the social aspects. And secondly, assessing various characteristics of a device, such as the comparison with standard benchmarks, or providing evidence for investors. We'd like to understand which of these areas are more or less important for you or your organization. Similarly, for the deployment and assessment tools, we'd like to understand how important you think it is to be able to compare different devices and locations, including having different types of device in your array. We'd also like to understand the importance to assess and optimize different aspects or characteristics of the project, such as the energy capture and transformation, logistics, operation and maintenance, or optimizing the balance of plant. There are a lot of these areas that we feel that the tools will be able to do, and we'd like to understand from our users which of these are most important or perhaps least important for the different types of user. Finally, there's space to add in any other comments, including what you expect to be most useful or valuable part of DToceanPlus. Thanks in advance for your contributions. This will help us guide the development of the tools to meet the needs of our users, which are people like you on this webinar. If you haven't already, please visit the questionnaire. The link is on your screen there. It is also in the webinar invite, and we've shared it on social media. It's edinburgh.onlinesurveys.ac.uk/DToceanPlus-user-needs. Thanks for your attention. If there are any specific questions or clarifications, we can address these now, but it's important to note the aim of the consultation is to get your feedback, including what is not clear about the project. Thank you very much, Incarnate.
Yeah, thank you very much, Donald. I think with this, we can finish this webinar. We will be really happy if you will spend now 15 minutes trying to fill in this consultation that we shared with you. And we are looking forward to receive your inputs and your feedback for the development of this project. So thank you very much, everyone, for joining us today, and have a good afternoon.